All right, for today, you guys should have already worked on Khan Academy. If you have not, when you are done with this assignment, you need to get onto Khan Academy and work for 20 minutes. That is all I'm asking. This should take all of maybe 15 minutes to do what this work here is. So I'm going to go over what we're working on. We are on the new lesson because we took our formative test already. This is lesson 2 of this unit, a slice of pie, sectors and segments of a circle. We're going to work on the warm-up and do 2.1, and that is all we're doing for today. If we look at the warm-up, it says determine the area of each circle. So if you have not downloaded, you will need to download on your iPad from self-service an app called Calculate 84. It is like the calculators that we use in school, so this is what you will need to use to help make this easier. So it says determine the area of circle. An area of a circle, the formula is A equals pi r squared. So you just take whatever the radius is and square it, meaning times it by itself, and pi, and there's your answer. We're going to leave this in terms of pi, though. So we look at number 1. We can set this up as A equals pi 7 squared. 7 times 7, I hope you guys all know that, is 49. And then we leave pi in there, and our answer is just 49 pi. That is all you have to do. I'm sorry, I lied. You have to write squared centimeters. So you can just do cm. So tell me what the unit of measure is. And anytime that we're finding area, it's always going to be squared. If we look at number 2, we take 9. We can go A equals pi 9 over 4 squared. And like I said, in our handy dandy calculator app, I'm going to see, I should have it on mine right here. If you go on your screen and you hit alpha y equals un/d, which gives us a fraction, hit enter. For some reason it didn't give it to me. Give me a second to get out of this. Alpha y equals, you don't have to hit the UD, you just hit enter right after, it gives you fraction. I'm sorry on that. So 9, arrow down 4, right arrow. And if you hit this little caret sign right underneath clear, gives you a second degree. You hit 2, enter, gives us 5.0625. So that's all you would have to write. You could write, flipping it back to make it a little easier for you guys to see, 5. We said 0.625, and we would say squared meters. So you can just put an M for meter, and that would be your answer. Now the last one, we know it's got to be our radius. This here is showing us that it's a line all the way through. Just like that. That means we are looking at the diameter right now. We need to know that diameter is half of the radius. Or I'm sorry, diameter is 2 times the radius. So this means we have to find the half. Half of 6.5 would just end up being 3.25. So we just write this as pi equals 3.25 squared. Once again, going back to the calculator, if I type in 3.25 squared, hit enter, gives me 10.56. Making it easy. Area equals 10.5625 squared inches is your answer. So again, area of a circle is area equals pi times r squared. We are not going to worry about the bullseye, so you guys can skip all the way down 2 pages to activity 2.1, where it talks about an area of a sector. So it says determine the area of a sector A. You multiply the area of the circle by a fraction that represents a portion of the area determined by the central angle of measure. Excuse me. So what this just means is, here's the formula that we will use. We know that the area of a circle is pi r squared, And to find out the area, we use whatever their central angle measure is over 360 times pi r squared. There's a proportional relationship between the measure of the area of a circle, sector A, and the area of a circle. So, area of the circle, right here, would be this. Area of a sector would be what we come up with here. And we know if we take the central measure, we set those two I gave the arrows to over each other, and we took the central angle measure over 360, they're going to be equal to each other. So for number 1, they have us asking right now that how does the formula to determine the area of a sector compare to the formula to determine the arc length? So we can say, if we remember arc length, that was our degrees over 360 times 2 pi r. So both formulas use fraction. So we could say both use fractions. To represent the circumference. I missed an E before that R. Circumference cut. So meaning taking those two together. It's not going to be something I ask you too much to do, but just so you understand that. And that's all kind of looking for that. Kind of nice and simple. Now, this next problem is going to talk about the dartboard here. So it says, the radius of the entire dartboard is approximately 225 millimeters. Okay. The innermost circle of the triple ring of the dartboard has a diameter of about 200 millimeters as shown. So they're saying, I'm going to put in pink, that the entire dartboard radius is from my pink line here all the way out. I'm going to actually make this a little thicker so you can see that line. So that pink line that I'm talking about right there is the overall radius. Now, what I'm going to put in the red, that's going to be a little thinner mark, they're saying is that the diameter of the inner circle is right here, what's in the red. Okay? I know it's not easy, but they're going to take us to the next page to see this. So just try to do the best that you can see. Next page on 2 says, Omid and Tanya each determine the area of each sector of the innermost circle of the triple ring. Identify the mistake that each student made. So if we look at this before we even read what they say, we should know that the radius of this circle here, the inner circle of the triple rings, if you don't know darts, this is a double, single, triple, and singles inside. So the radius right here should be 100 millimeters because our diameter is 200. We always know our diameter is 2 of the radius. Radius is half of the diameter. So we look at this. So each sector from Omid, each sector of the innermost circle of the triple ring has the same central angle measure as each sector of the dartboard. I know that the area of the dartboard is 50,625 pi square millimeters. I can divide this by 20 to determine the area of each sector of the innermost circle of the triple ring. So, Omid, if we sit here and figure this out, so we take the area of our big circle. Let's look at that one. Actually, I'm sorry, they're taking a look at the inner, so let's look at the inner. So we know the inner radius is 100, so we can find out that the area of that is equal to area times pi times 100, because that's a radius, squared. Fancy dancy calculator you pull up. I'm using took one from school to use for this, or my personal one actually. And if we go and we type in 100 and square that, we end up getting 10,000 pi millimeters is what the area of the entire inside circle is. Now let's see what the area of the outside of the entire thing is. So if we go the other way of the 225 millimeters, So we do 225 squared. 225 squared. Whoop. Accidentally hit it twice, sorry. 225 squared. Our big circle is 50,625 pi millimeters squared. Now, if we look at Ohmid, Ohmid thought that if two sectors share the same central measure angle, they would have the same area. But the sectors of the innermost circle of the triple ring will have a smaller area since the radius of each sector is less than the radius of each sector of the dartboard. Fancy terms, that's reading from up top above. I'm just going to put an arrow here. We can say inner circle will have smaller area since it's actually obviously a smaller size. Now let's look at Tanya. Like I said, for Ohmid, there's a lot, but that's all I really want you to know. For Tanya, Tanya's saying the radius of the dartboard is 225 millimeters, and the radius of the innermost circle of the triple ring is 100, which like what we came up with. 100 over 225 is equal to 4/9. So the area of each sector of the innermost circle of the triple ring is 4/9 the area of each sector of the dartboard. What Tanya, if we look here, I'm going to highlight it so you see exactly where I'm talking about. Tanya forgot that to do the area of a circle, you have to square. So area of a circle, you, and I write in big bold letters so you see it, have to square the radius. Sorry if my writing's not the greatest. I'm zoomed out so you guys can see both. But here, instead of just being 4/9, it should be 4/9 squared to solve the answer. That's where she was wrong on this. So what we have to do now on number 3, which we have number 3 and 4, and that's it for today. We might even skip 4. I'm going to see what it's about. But number 3 is asking us to calculate the area of each sector of the innermost circle of the triple ring. So let's look at doing this. So we know already area by looking at the top up here. So I'm trying to get up to it for you guys. Central angle over 360 times area of circle. So we know 360 is going to be a full circle. Oh, sorry. And we know if we look at a dartboard, which I don't know if many know, there are 20 total spots that bounce around every which spot around here. Okay? So there's 20 total spots. So we know it's going to be over 20. So 20 over 360 times pi r squared. Now, rewrite this. We can simplify this down. 2 can divide that by 2. So that's technically 1 over, I'm sorry, I completely lied on this. Erase this stuff here. We're looking at each sector. So we know that there's 20 pieces. I'm wrong on this. So there's 20 pieces. And we're looking at what is the area for each individual one. So you would just do 1 over 20. 20 meaning for the dartboard. I'm trying to write this in here for you guys so you can see it. Dartboard. Zones. And this is the number of zones we're talking about. Just so you understand where I got those numbers from. So now we know what the radius is. We said of the inner circle is 100. So 1 over 20 times pi parentheses 100 squared. We look back up here. We hit our number up here of 100 squared is 1,000 or 10,000. So it'll be 1 over 20 times 10,000 pi. And using your calculator, take 1 over 20 times it by 10,000. Ends up bringing you to being your area is equal to 500 pi squared millimeters. So I'm just going to put it as mm, so you don't have to write out millimeters. That would be your answer. Number 4, I'm going to skip, so we're going to be done there for today. Make sure you are filling this out. When we are done with this lesson, you will submit this to me, and I will be giving you a work habits grade as well as putting this as in the grade. So make sure you are doing this and writing the work down. If you need to rewatch the video, slide through so you fill in the pieces that need to be filled in. I know what it's going to look like, so if you're skipping parts and not doing it, it's going to count back against you. If you have any questions at all, do not hesitate to reach out to me via email, and I will respond as soon as I can. I am typically have it on my phone or have the computer up next to me, so I will be able to respond as fast as I can and assist you on anything you need assisting. Hope you have a great day. Don't forget to do your Khan Academy, and I will submit a new video for tomorrow's lesson.